Uh, Hi guys. Yesterday, who all are left with the presentation? Just remind me, please.
I'm Priyanshu.
Priyanshu. Okay.
Yes, ma'am.
Okay.
I can start
Soumya.
the presentation now.
Okay. Okay. Soumya was supposed to present first, right?
Yes.
Ma'am, after Soumya, I can
Okay.
present, ma'am.
Okay. Soumya, then
And
Sangeet,
then
right?
I can. Priyanshu.
Okay, fine.
Yes, ma'am.
Okay. Just a minute. Priyanshu. Okay. Next, anyone wants to present?
Dhanush.
Okay, Dhanush. Fine. After Priyanshu, Dhanush will present.
Ma'am, after Soumya, I can present, ma'am.
Yeah, I already mentioned. After Soumya, Sangeet will present, then Priyanshu, then Dhanush. Next,
Service.
anyone else wants to present?
Ma'am
Guys,
Sajruddin.
sorry. Sajruddin, yeah. Okay, fine. So as of now, we are counting for this 5 people. Okay. So if we do have time, after that, we'll continue to take other persons as well. Okay. Varsha, Dikshant, please wait. We'll go ahead with this 5 people first. If time allows, time permits, we'll see yours as well, the presentation. Fine? Okay. Okay, first is Soumya, right? You can start presenting. Just a moment. So I just want to ask, is there anyone who is new to this class? Like today is their first session like this? Anyone?
Yes, ma'am.
Yes,
It's me,
ma'am.
Aryan.
Okay, okay. Aaron, today is your
Yes,
new,
ma'am.
like the first session, right?
Yes, ma'am. Right.
Yes, ma'am. Okay, fine. Okay. Got it. So two of you are there, right? Three. Okay. Okay, got it. So the thing is, as of now, they are actually what they are doing. They are presenting previous week's project. Okay. So the first 1 hour will see and go ahead with the presentation thing, and then after an hour we'll start with the today's session. Okay, this is the way we actually goes. Okay, so as of now, you just see their presentation, how they have prepared their project, because you people also have to do the same. Okay, and whatever be the class you have like left off, like you haven't gone ahead with because today is your first session, so accordingly, the details of recordings will be provided to you so that you can don't miss out anything, right? And after the session, just wait. Like after the class is getting over, like we just keep a 10-15 minutes window open. If any doubts you are having by then, I will definitely answer you related to the course. Or if you want to see the structure, core curriculum, and how the stuff how the way we are going ahead with that also we will be discussing. Okay, Aaron, Sandeep,
Okay, ma'am.
okay,
Yeah.
okay. Sandeep, Kajal, Aryan, and who is left? Who is there as new? Who have just Sandeep Kumar? Yes. Anyone else? This three-person, right? Okay. Shubroto Shaha. Okay. Sparsh, Kajal. Okay. So as discussed, after the session gets over, we'll keep a 10-15 minutes window open. There we will be discussing the details on. Fine. So as of now, they will just present. You just see how they are presenting because you also have to present in the similar manner. Fine. Okay. So Soumya, you can just start your presentation. You can just share your screen and start.
Is it visible?
Yeah, I do.
Good evening, everyone. I'm Thomasing, and today I'll be presenting my project on insurance claim and fraud analysis. The main goal of this project was to analyze claim pattern, identify fraudulent behavior, and extract meaningful insight using exploratory data analysis. Fraud detection is important for insurance companies as fraudulent claim can lead to heavy financial losses. So let's get started. First, I have imported the necessary libraries like pandas and numpy for data handling, matplotlib and seaborn for statistical visualization, and plotly for interactive graph. And I've also used sklearn for pre-processing and missing those for visualizing the missing data values. I have mounted mounted the file using Google Drive, and there is also an option to mount it through the GitHub link, in which I have uploaded the data set. Here we are simply just reading the file and printing the number of columns and all the data columns present in the data set here. This rule this part of the code prints the initial rows of my data set. It has a dimension of around 1,000 entities, 1,000 rows, and 39 columns. Uh, I didn't actually use all the columns, but I tried to use at least 10 of them. Here I'm checking for the duplicate values, but my data structure was already cleaned, so there was not many, there was no duplicate value, but it did had some null values in one of the uh, columns or features in the authority contacted. Here is the visualization of the missing values using the missing no libraries. These are all the columns present in my data set, such as customers, age, policy number, policy bind date. Here we are using the age, incident date, and police report availability, property claim, and total claim amount. Fraud reported. Fraud reported is actually the flag value if the claim was a fraud or not. Going further along, this is the dataset description. All the counts, mean, standard deviation, minimum and maximum values. This is the variable description. For data wrangling, I actually removed some. I, I performed extract, duplicate, and removing, but there actually was not any duplicate present. I did fix the consistencies, as in the police report availability column. There was many points which shows as the question marks, which I interpreted as no. It already had yes and no values, but for the question mark, I converted the question mark as not reported. For handling the missing value, first I calculated here the total missing values, which was around 106 in one column only. And then the column was authority contacted. For that, if the value was missing, it meant that it was not reported. So I filled in the value as not reported. This is the visualization before and the total value missing value left after handling. For analysis, here I have plotted the distribution of fraud versus non-fraud claims. The graph shows that the fraudulent claims are fewer compared to the genuine ones. However, they are important because they typically involve higher financial amount and irregular patterns. This imbalance also indicates the imbalance in the actual claim and the fraudulent claim in the real world data set. Here is a box plot of claim amount by fraud. Here we can see this is the y-axis is the total claim amount, and the x-axis represent if it was a fraudulent case, it is y, and it is if it is not a fraudulent case, it is indicated as n. Here we can see that in the uh, where there is a fraudulent indication, there are many outliers. These outliers have been treated because they are important to identify if the case was a fraud or not, or a genuine one. Next, I have plotted a histogram for claim amount for fraud. Here we can see the number, although the number of uh, non-fraud cases are higher, representing the real world scenario, but we can also see that in the range of 40K to 80K, there are more number of fraudsters appearing, and they target a lower payout. As we can see here, the range, the non-fraudulent applies for or claims for is different than that of the fraudulent cases, slightly different in some cases. Here is a box plot of claim amount by police report availability. Here we can see, as we have already seen, that there are outliers in the cases where uh, there is a fraud or reported, and this is the and the y-axis represent yes as the police report availability and no as police report not available. Here we can see if the police report is not available, there are more outliers in the data set for reported fraud. Here I've made a bar chart for fraud rate by police report availability. Here we can see if there was no police report available, the chances or the ratio or rate of the fraud is more as compared to when the report was not when the report was available. There was less fraud cases. Here I have plotted a bar chart for fraud rate by authority contacted. In authorities contacted, uh, fraud rate are broken down by which authority was contacted, like police, fire department, or other ambulance or other. And no, not reported is the not reported was actually the missing values present in the data set. We can see that the fraudulent usually prevents not to involve external bodies, like to avoid external checking, or like if the police was involved, they might be suspicious of them. And here other authority means directly contacted or directly reported or reported by a third party. So we can see in this scenario the fraud rate is higher as compared to others. And we can also interpret that in which the cases in which the police was involved as the reporting authority, the fraud cases are less there. Here I have plotted a scatter plot for each was claim amounts. It shows the various ages and the claim amounts by, and the red value shows that it is a fraudulent case, and the blue dots represent that it is not a fraud case. The result shows that while genuine claim followed logical relationship, fraudulent claim appears as anomalies, like we can see here. The claim amount is higher. The average claim amount is higher than that of the genuine ones through these dotted lines. Here I have plotted a scatter plot for claim amount versus policy premium. Here I have plotted it together as well as separately here. We can see here that the two scatter plot, that in the fraudulent the higher amount is claimed. As we, for example, if we see at the premium amount of 1,000, the claim applied for is around 57.86K. And here for the same premium amount, the claim is less in the non-fraudulent claim case. This shows that fraudulent claim are often often bring the usual relation shows by the premium amount and the total claim. Fraudulent often attempt to claim far more than the policy realistically justified. Here I have taken the average claim by age and fraud. This the y-axis represent the average claim amount, x-axis represent the age, and the red bars represent the fraudulent case, and the blue bars represent the non-fraudulent case here. We can see that the claim made, the total claim amount made by the fraudulent case are way higher than the those of the genuine cases. For different age groups, we can say that age group does not actually affect the fraud or non-fraudulent cases, but we can identify it by claim amounts. This is a correlation heat map. I plotted a correlation heat map of numerical feature. The key finding was that no single value strongly explained fraud by itself. Fraudulent pattern emerges only when multiple factors are considered together. This shows the importance of multivariate analysis for this fraud detection. The key insight and conclusions from all the analysis are that the fraudulent claim are inflated and irregular. We can also say the absence of police report or authority involved strongly correlate with the fraud, and fraudster often break logical trends between claim amount and the policy values. We can also say that the fraud is spread across the demographic through some group showing higher risk. And the multivariant analysis is essential for detecting the fraud. It cannot be detected by a single one. Thank you. That's all from my side.
Okay, Soumya, fine. You can stop your screen sharing. Next is Sangeet, right? So you're
Yeah,
ready?
yes, yes, ma'am. Yes, ma'am. I'm ready, ma'am.
Okay, fine. So
Yeah,
you just
can you hear me,
present your
ma'am?
screen.
Can you hear me
Yeah,
clearly,
yeah, I
ma'am?
can hear. Yeah, I can hear you properly. You
Yeah,
can
okay,
just
ma'am.
share your screen and just explain.
Yeah, okay, ma'am. Okay.
Yeah. Guys,
Yeah,
everybody have submitted a week two project, right?
yes, ma'am.
Guys,
Yes, ma'am.
in the mail ID itself, you have submitted, right?
Yes, ma'am.
Okay, everyone, like except the new
Ma'am,
paper. Yeah. Okay, okay, got it.
ma'am, is that my screen is visible?
No, your screen is not visible for me.
Yeah, just a minute.
Rekha, you're saying something?
Ma'am, now it's visible, ma'am.
Yeah, Sangeet, it's visible.
Yeah, okay, ma'am.
You just wait a minute, just a minute, Sangeet. Rekha was saying something. Yeah, Rekha, tell.
Yeah, okay, ma'am.
Ma'am, I was like traveling somewhere, so can I submit it on Thursday?
On Thursday. So try to cover
Yeah,
it by tomorrow, no? Like by Wednesday, if possible.
I'm out of town for so and uh, it is and there is
Okay, okay, got
network
it.
issue.
Fine.
So yes, ma'am.
Okay, fine. You submit it. Fine.
Okay, okay, ma'am.
Okay,
Thank you.
Sangeet, you can just present your screen.
Yeah, yes, ma'am. I can start, ma'am.
Your screen is not visible. Others can see his screen. Can you please confirm?
No, ma'am.
No, ma'am, it's not visible.
No, ma'am,
Yeah,
it's not
okay,
visible.
okay, ma'am. I'm sharing it.
Are you facing any network issue?
Now it is visible,
Yeah,
ma'am.
please.
Now it is visible.
Yeah, no, no, not visible.
Not visible. Just a minute.
You do one thing, you reconnect by the time Priyanshu will present, and after him, you can present. Fine, Sangeet?
Yeah, just a minute, ma'am. 1 minute, 1 minute. I'll try. Now it is visible, ma'am. Ma'am, now it is
Yeah,
visible.
no, not visible. Not
Yeah,
visible.
okay. Okay, okay, ma'am. Yeah, okay. You can
You
present.
just
After that, I will
reconnect
present.
once.
Yeah,
Yeah.
okay, ma'am. Yeah, okay.
Yeah,
That's fine.
Priyanshu, you're ready?
Yes, ma'am.
Yeah, Priyanshu, then you can just present your screen and start the presentation.
Is my screen visible?
Yes, it is.
So, hello all of you. Myself Priyansu, and today I'm presenting the topic project. My topic on title cyber attack by industry sector. So, the objective of the project is to analyze and derive actionable insight into the global cyber attack patterns. The primary focus is to understand attack type, industry specific, and risk and strengthening the cybersecurity posture of the industries. And the problem statement is to in this problem the increasing frequency of cyber attack in all industries, which industries are most vulnerable, the attack type which are dominant across the timeline, and the resolution time. Let's start the data analysis. So firstly, I import all the required libraries. Pandas is for data handling dataset, Matplotlib and Seaborn for static plots, and NumPy for calculation, and Plotly Express for interactive visualization. Together, these give powerful tool to analyze and visualize cyber security trends. Here I loaded the dataset and printed its information. Show the number of rows and column, data type, and missing values. This gave me the first impression of the dataset structure. Then the description about the dataset. Here I then use the describe the view summary statistic of the numerical column like mean, standard deviation, minimum and maximum values. This is a useful to spot extreme values or trend in the dataset. Then information about the column. This helps to understand the kind of example, the text data like in the industry and the numerical data for financial loss. This could now incident by year. This could count how many incidents happened in each year and sort them accordingly. It gives me an overview of how cyber incidents have increased or decreased from 2015 to 2024. Then I displayed the first 5 rows to quickly check the raw data. This helped confirm that the dataset has been read correctly and give us the preview of actual entries. Then I calculated the most targeted industries and attack type. This tells us which industry face the most attack and what kind of attack are the most common. Then the average financial losses. This group the data set by attack type and the calculate the average financial loss. Sorting it help us to which attack can cause the highest average damage. Like in attack type DDoS attack, like in DDoS attack, 52.03 million is like financial loss and so on. Then the unique value. Here I check how many unique values each column has. For example, how many different countries, industries, and attack type are present in the data set. Then this bar chart show the total number of attack per industry. It highlight which sector are the most vulnerable. For example, financial, healthcare, and IT are usually as the top. The IT sector is the most targeted, and then the banking, healthcare sector are next most targeted, and telecommunication, government are also in the list. So yeah. Then the bar chart in the times this line chart show how many users were affected each year. We can observe peak in certain year indicating large scale data breaches. And 2019 it is the lowest affected the user. Then average user affected the industries. Here I calculated the average number of affected user per industry. The bar charts show which industries on an average impact the largest user base when an then the double bar chart financial loss and the resolution time. These charts compare average financial loss and average resolution time for each attack type. It gives a two-dimensional view of how damaging and time consuming different attacks are. Then this is the interactive chart. This interactive bar chart show the total financial loss for each attack type by hovering over bars. Like in man in the middle attack, the time it show the attack type man in the middle and the financial loss in millions. Then in malware also the financial loss is $23,967 million, and in DDoS attack the financial loss is over $27,630 million. Then the number of attack by year. This line chart show how the number of attack has changed each year. It helps visualize to attack attacks are increasing over time. Like in 2016, the number of attack are 285. Then in 2017, the number of attack are 390. And 2018, the number of attacks are 310, and so on. Then this is a sunburn chart. Attack distribution. This sunburn chart is hierarchical. It shows attack distribution from attack type to industry and then to country with financial loss as the measure. Like these are the categories like phishing. These are the attack categories. Then the industry according to the attack type. Then it show
Priyanshu,
the
just a minute.
yes ma'am.
I guess your screen has stuck, so I cannot see the chart. Can you scroll it down?
Yeah. Is it visible now?
No, no, I cannot see. Can you just reshare once again? Just
Yes ma'am.
stop share and then reshare it again.
Yeah. Now is it is visible?
No, it's not visible. So guys, can others can confirm like is it visible or not? Like for me, it is
No,
not
ma'am, it's
visible.
not. It's not visible, ma'am.
Yeah. Okay, fine. Thank you. So Priyanshu, it is not visible. I guess you are also facing
Um,
some network issue.
yeah. Now
I
is it visible?
no. Till now it is not visible. Yeah, now it is visible. Yes.
Yes, ma'am.
Can you
So,
scroll up?
yes, ma'am.
Scroll up. Okay, go to like after the bar chart, the first slide, go to the very first cell,
Yes, ma'am.
very first cell. Oh, now slowly scroll down.
Okay, ma'am.
Okay, okay. Now scroll down. One bar chart, you not the interactive plot, the only bar chart you have used. That plot you come across
Ma'am,
is
what?
the initial plots. In the initial plots, not the interactive ones. The
Yes, ma'am.
initial plots, like let me show me the initial plots that you have done.
Okay, ma'am. Ma'am,
Your screen is not visible. Yeah. Okay.
yes, ma'am.
Scroll it up. Yeah, this one. Right.
Okay, ma'am.
So, start your presentation from here because in between, some of your plots were not visible, and you have explained, I understand, but your plots was not visible because there was
Yeah.
a issue with the screen. You started from from that, like from that bar chart. That is the first chart, right? The
And
blue bar
the
chart.
first shot is this. Yes, ma'am. Yes, ma'am.
Okay. So
And
start
now is
from
it
that one.
visible?
Yeah, it is visible.
Okay. This bar chart is show the total number of attacks per industry. It highlight which
Uh,
sector are
See,
most
it is not showing the bar chart. It is showing the group by like the line chart. This
um,
one. Yes.
yes, ma'am.
Yeah.
The
Now
bar
it's
chart
showing the
show
bar chart.
the yeah.
Yeah. Start.
Let me start. This bar chart show
Yeah.
the total number of attacks per industry. It highlights which sector are most vulnerable. For example, finance, healthcare, and IT are usually at the top. As you can see in the bar chart, IT is the most targeted sector in the cyber attacks, and the least targeted is the telecommunication, according to the data set from 2015 to 2024. Then the line chart. This line chart is according to the time series affected user over time. Show the how many user were affected each year. We can observe peak certain years indicating large scale data breaches. Like in 2015, 2017, it is the peak, and 2022, and the least in 2019. Then the bar chart, according to the average user affected by the industry. Here I calculated the average number of affected user per industry. The bar chart show which industries on average impact the largest user base when an incident occur. Then the double bar chart, financial loss versus according to the resolution time. This chart compare average financial loss and average resolution time for each attack type. It gives two-dimensional view of how damaging and time consuming different attacks are. Then it is an interactive bar chart, total financial loss by attack type. This interactive bar chart show total financial loss for each attack type by hovering. we can see exact values. Like in DDoS attack, they show the attack type DDoS and financial loss in millions to 27,630 millions. So as in malware also, the attack type is malware and financial loss is 23,967 million. Then the number of attack, and then this line chart show how the number increasing and decreasing over the years. It helps visualize trend and whether attack are increasing over time. Like in 2015, the number of attack are 277, and in 2016 the number of attacks are 285, and so on. Then the Sunbrush chart attack distribution. The Sunbrush chart is hierarchical. It show attack distribution from attack type to industry and then country with the financial loss as the measure. It gives deep drill down into the attack pattern. Like in phishing, we have in these are the categories of attacks. Then the types of industries, and then the countries. Like in phishing and in the attack of in the industry of IT, it show the like in UK, the financial loss is over $599 million, and it is a type of phishing attack. So then the financial loss and affected user. Finally, the scatter plot show the relationship between the number of affected user and financial loss. The bubbles are colored by attack type, and their size represent the scale of financial loss. I applied log scale to better visualize mm, like this. So as you can see, these are the bubble show every bubble show the attack type, their financial loss, number of affected user, and the country of in which the attack was used. So that conclude the full walkthrough of my project. We explored the data set, identified trends, analyze industries and attack type, and visualize financial and user impact using both static and interactive data set. Thank you, ma'am.
Okay, Priyanshu. So how you have just loaded the data? Have you used the like collab or drive anything? How you have used like
No, ma'am, I
taken?
uploaded the file here in Collab.
Okay, okay,
Yes, ma'am.
you uploaded. So
Yes, ma'am.
why didn't you use like from collab like Google.collab import drive?
Ma'am, because this is a simple way.
That is simple, but if you are
Yes, ma'am.
having this runtime error now, then this
Yes, ma'am.
file will be removed, right?
Yes, ma'am.
Then if I want, I tell you just run the specific code, it will not run, right? Because the data set won't be here.
Yes, ma'am.
Okay,
After the runtime
okay.
end.
Runtime, yeah, yeah.
Yes, ma'am.
Like because if there is the run, like there is a runtime, the runtime error is done, like then this file won't be here anymore. It's
Yes, ma'am.
not
Yes,
like
ma'am.
if you upload it also, then also this won't be visible, like this data set. So try to do it using the drive or you
Okay.
can do it using the GitHub also. You
Yes,
can
ma'am. Yes, ma'am.
upload the file in GitHub, and from there also you can use the path, and then you
Yes,
can
ma'am.
use the like accordingly how you just call the file, like the load the CSV file in that format.
Yes, ma'am.
Okay.
Yes. Okay, ma'am.
And also in your presentation, the conclusion is left, like you haven't mentioned the conclusion. Okay,
Okay, ma'am.
from next project, try to include the conclusion.
Okay, ma'am.
Okay, okay,
Yes, ma'am.
okay,
Thank you.
fine, Pranshos. Okay, bye. So accordingly, Sangeet is there, right? You are
Yes, ma'am.
done. So have your issue been resolved? You could just present the screen. Let me just see.
Yeah, yes, ma'am. Yes, ma'am. Now it is visible, ma'am?
Yeah, yeah. Now it is visible. You can
Yeah,
just start off with the presentation.
yeah, yeah, yes, ma'am. Good evening to all of you presented in this class. Let's today my project is gender-based mental health analysis in technical professionals. It was created by me and OSMI means stands for Open Source Mental Illness, the organizations that runs the mental health in the so industries. This is the database which I have taken. And let's start the project. Project title is a gender-based mental health analysis in tech professional. Mental health in tech industries. Why it matters? The tech industry is a fast-paced and highly competitive, constantly evolving. While it provides opportunity, it also places heavy mental and emotional demands on professional. Mental health in technique is not just a personal issues, but a workplace and organizations concentrate because it directly impacts productivity, innovations, and employee retentions. Second, uncommon mental health challenges in technical issues. What are the common mentally challenges we are facing? Anxiety and stress, burnout, depressions, imposter syndrome, and what are the sigma for the imposter sigma? Fear of being judged or disclaimed against if the mental health issue or disclosed. Domain. What the domain I'm using? Healthcare, workplace, mental health, and data analytics. Objectives. Objective for this project to explore how gender, organizational supports, and workplace culture offer mental health issues such as anxiety and depression among technical professionals. While starting this process, I have some research questions. What are the questions? Does the gender influence like the likelihood of experiencing mental health challenges? How does organization supports impact employee well-being? What are the common accident triggers in the tech workplace? And the answer for that one, yes. For first question, does the gender influence the likelihood of experiencing mental health challenges? Yes, gender has influence. Female and non-binary response reported high level of anxiety, stress, and treatment seeking compared to males. Men are less like to seek treatment, possibly due to stigma. This suggests that gender-sensitive mental health support system are needed. Second question: how does organization supports impact employee well-being? Organization support has a strong positive impact. Employees who combines provided mental health benefits, HR policies, and awareness programs show longer anxiety and eye openings to seek the help. Workplace without mental health policies often see employees hiding struggles or avoiding treatment. Conclusions for that one: employer provide supports reducing stigma, encourage treatment. The companies can encourage the treatment and improve the overall well-being. And third question: what are the common anxiety triggers in each tech workplace? The survey and analyzing highlights key workplace and anxiety triggers. Long working hours and poor work-life balance. High job demand with little flexibility. Lack of support organized cultures. Managers, HR are not trained in the mental health awareness. They are not creating the awareness of for this one. Fear of being judged or discriminated against for disclosing mental health issues. Limited or non access to counseling or therapy resource. Datasets. The fifth step is dataset. I taken the dataset source OSMI mental health in tech survey opening source mental illness. Futures used gender. Have you short treatment? Does employer provide mental health support? Work factors, stress, remote support culture. Methodology. First is data cleaning. Standardized gender response male, female, non binary. Removed missing values. Exploratory data. Exploratory data is a process of analyzing and visualizing data before applying advanced models. It helps us understanding the structure of the data and detecting the missing values, outliers, or errors, identify the patterns, relationship, and trends. Answer the key research questions. Gender in distribution survey anxiety and depression rates across genders, correlation between organization supports and mental health openness. Visualizations. These are the input we are going to get. These are the output we are going to get. Pie chart, gender split, bar chart, anxiety rates by gender, heat map, workplace support versus anxiety levels. Key findings, 7 steps. Gender difference. Women reported higher levels of anxiety compared to men. Non-binary report shows the highest mental health challenges. Organizational support. Companies with clear mental health policies shows longer anxiety tiers. Lack of HR supports mental health outcomes. Anxiety triggers identifyings. Long working hours, lack of fixable policies, stigma around discussing mental health at work. And finally, eighth one is insights for the organizations. Implementing mental health policies openly provided anonymous counseling service, encouraging work-life balance with flexible training manager to recognize mental health stigmas. And we are going to do in this program coding for this one. We are going to import libraries that already have been imported in Colab. It is already presented and importing pandas, and I am importing MetaLab and Seaborn as SNS and NumPy as NP. So first we are creating a mock data based on the descriptions which I have taken from the data equal to PD that format, and we are using this format and we are presenting. And let's second coding for pie chart. We are gender splitting that one. We are using this one. Gender counts equal to data, gender values counts, and this one. And the second one is bar chart, anxiety rates by genders, and we are using. And it map for workplace and support versus anxiety levels. While we are running this code, we will get the output like this. Let's I'm going to run this one again. Yeah, I run this one and I got the output. Gender descriptions of tech profiles. First one for the this one. Yeah, for pie chart, we have got the output of this one. Male, the rating of how many males are working in that one. Male and non-binary and female. 25% of male are there and 30% of females are there. And non-binaries, 45% are there. 45 percentages. And second coding is for bar chart. For bar chart visualization. For bar chart, we getting this one. Anxiety treatments syncing by the genders. What are the treatment, short treatment we have to give? First, number of the professions. This side shows that number of the professionals, and female, it shows females, and it shows male gender, and it shows non-binary. And we have you short treatment. We are giving yes or no. This one will be considered as the yes. We need to give the treatment, and this one is no. That we don't need to give the treatment. And final, the third one is we are using heat map. Heat map for workplace support versus anxiety levels. So we are going to see that workplace versus anxiety treatment. In this one, does your employees provided mental health supporter? This one, this row column, this rows will shows that employer support. This rows columns will shows that employee support, and this one and column which shows that treatment, short treatment, which shows that short treatment, and the inside value which shows the category, how many numbers are there, how many persons are there. It shows the 22 is the category of the persons. And final conclusion for this project, the OSMI mental health in sector-wide analysis shows that gender difference exceeds women and non-binary profession reports higher anxieties and mental health subjects compared to men. Women and non-binary profession reported higher anxiety and mental health subjects compared to the men. This indicates that gender and sensitive supporter systems are needed in one place. Organized supports matter. Organized how supports the matter. Employees with access to clear mental health policies and HR supports are less likely to suffer from the untreated anxiety or depressions. Lack of supports, they are not supporting their that HRs and team leaders are not supporting, they are not providing that correct treatments or how to overcome that one, they are not providing in that companies. So lack of supports increasing workplace stresses and sigma in company. For example, if you are going to a company while we are doing all of the works, all of them, and that time we will get stress, depression, all of these things. The company has to plan to give some activities like Friday, fun Friday, like that. Like I have been working in teach new company as 3 months I have worked here. They will keep in Sundays and Fridays or some other days. They will take some 1 or 2 hour times, and they will spend the time to reduce the depressions and all these activities. They will do some activities like walking, dancing, or some. They will make some program. Then it will help us to reduce our stress. All these things, and we can go through while we can go to medically to reduce our stress also. And main answering triads identifying long working hours and problem work life balance, fear of being judged when disclosing mental health issues, limited or non-employee provided mental health resource, recommendations for organizations, introductions mental health awareness training for managers. We need to introduce, that means we need to tell, or we need to tell the managers to give the we need to create the awareness as an employer. It is it's our necessary things to create awareness to the managers, uh, to keep the activities or to help us them to reduce our stress levels, and provide counseling service and ensures anonymity, provide flexible workers options to reduce stress. They can give us a time. They won't need to take the work for as long as they need. Just they need to give time as how we can able to do that work, and we can able to complete that work. And what the time we required, we can take that time. They no need to use as how we can. They can give us that what the time we required, that time only they need to take us and work. And mental health is a critical factor in tech industries because of the job demands can easily lead to anxiety, stress, or burnout. Companies that invest in mental health supports not only improve the well-being of employees but also gain higher productivity, innovation, and loyalty. And that's all about my project. And thank you for giving me the wonderful opportunity, ma'am. That's all, ma'am. I am done.
Okay. Okay, you can just stop your screen sharing. Okay. Uh,
Yeah.
okay, so for today, we'll start off with today's session. The rest, I guess, Dhanush was left after Priyanshu. His number was there to present. So, so we'll discuss about this. Okay. So as of now, we'll just start off with today's session. Okay, because we had to complete our today like this week agenda as well, right? So, and those who are having doubt, who have joined today and having any doubt, so after the session, we'll keep a 10, 15 minutes window open. There you can directly ask whatever be the questions that you are having. Okay? Okay, guys? Understood?
Yes, ma'am.
Okay,
Yes, ma'am.
fine. Okay, I'm just presenting my screen. You just let me know is it visible to you or not. Fine?
Yes, ma'am.
Visible?
Yes,
My
ma'am.
screen is visible. Okay, fine. Got it. So yesterday we basically started off with supervised learning. Okay. How we have gone ahead with, we have discussed about supervised learning and what are the types of basic two types of supervised learning, how we can include it up. So this all we have discussed in yesterday's session. So we'll just pick it up from there and we'll move accordingly. So today we will be discussing how like supervised learning works, in what format it is working. So what is the proceedings of training a model, how we are doing the training and testing in the data that we will be considering, like looking into, and eventually we will be moving into and understanding about the types, what are the different types of like the supervised learning mechanism, and what is the training proceedings. All we will be discussing in details. Okay. So let me just recapitulate for some, for the ones who have joined today itself. Today is their first class. So yesterday we have gone ahead and started about learned about supervised learning. So what supervised learning is? So supervised learning is like teaching a child like with the help of flashcards, or this we are generally making any kindergarten student understand anything, right? So similar way, supervised learning is like teaching a child with the help of examples. Okay, so this is how like what supervised learning is all about. So we you show like in case of machine learning, supervised machine learning, you give the input, like whatever be your question you are giving to the machine, and you are getting the answer as an output. So all this are already been given to the machine. Okay, so this is what the machine learning, like the overall in gist, if you can think of, this is what machine like supervised machine learning is. So basically, supervised machine learning learn from the previous data that has already been given, and based on that, it goes against and try to predict or understand the pattern that is there in the old data, and based on that, predict new things. Okay, so this is supervised learning. So today we'll covering how supervised learning actually works. Okay, so in case of supervised learning, we are covering the major areas that are like uh, data collection, then training and modeling, test the model, and use the model. In a very short and simple way, supervised learning is working in this format. So before going ahead, just let me just give you an example so that it becomes easier for those one who have just joined. So let me just take an example of prediction. Okay. So the example would be predicting the house price. Okay. The very common example I am taking it off. Okay. So this is the example that we are considering, predicting the house price. So then we will be having the input. So that we are considering at X, input that we are considering as X. X is the independent variable up here. So are you people able to see my screen? Is it properly visible?
Yeah,
Or
yes,
should
ma'am,
Ma'am,
I
it's
just zoom it
visible.
out?
yes, ma'am. Zoom it a
Yes, ma'am,
little
it's
bit.
visible.
Okay, okay. Fine. Now it is clear?
Yeah, yeah, now
Yes,
it's
ma'am.
clear.
Yes, ma'am.
Okay, okay. Got it. Fine. Okay. So input, what we are taking the size of the like the size of the house in square feet we are taking. Okay. So this is X. That is the input that we are giving to our model or the machine you can think of. And the output we are taking, output we are considering, that is Y. And this is the dependent variable. It is depending on the output is depending on X. Okay. So input X is the independent. So let me just write it for you. X is independent. Okay. And Y would be the dependent one. Okay, and in case why, what we are trying, like what we have to predict from the size of the house, the price of the house. Okay, the price of the house, we need to take it. So now we, for the first step is data collection. This is the first step that we need to do. So we will collect data. So let me just think of getting the data of like X, the values that we are taking it as, suppose 1,000 square feet, 1,500 square feet, maybe 2,000 square feet, and 2,500 square feet. Okay. So accordingly, we'll take the value of Y. So Y value we will be taking Y, that is the price of the house, right? So what would be the price of the house for 1,000? Suppose 1,50,000 may be the price of the house. For this, next, this is 2 lakh. Suppose for this, we can think it of 2,50,000. And for 2,500, we can take it as 3 lakh. Okay. So this is the data that we have collected. Suppose we have collected this data, and accordingly, this data is been given to the machine. Okay. So this is the input, against this is the output. So these are the labels. This Y basically are the labels. So if you can think of X, we basically call it as X, we basically call it as the features or the inputs, and Y we are generally calling it as the labels. So X is the features, Y is the labels. Okay. So against this feature, that is 1,000, that is the size of the house, we are getting the label or the output value as 1,50,000. For each of the features, we are getting the labels like this. So this data is being fitted or given to the machine learning model. Okay. Okay. So now what we need to do? So after we are getting the collected data, after we have collected data, so now suppose the computer, like the or the model, what it looks at the data and learns, l- like it tries and understand the hidden patterns. What it tries to understand the hidden patterns. So based on that, what hidden pattern the person is getting, the model is getting, that is bigger the house, that equals to the rise in price or the higher in price. So we can write it as the hidden pattern that is that the machine will got, that is bigger house, that would be equal to higher price. Right, guys? Understood? Everyone?
Yes, ma'am.
Yes, ma'am.
Okay, got it. Fine. So
Yes, ma'am.
now, okay, got it. Great. So now, if someone, like, suppose I am asking to the machine, like, I have a query, so I just want the price of a house whose square feet is 2,200. Okay. So let me just get it. Like my X, that is, I'm giving the input to the machine, that is 2,200. Okay. So now what the machine will predict? So this all are given data. So this actually is this all are actually training data, right? By this data, I have trained my model. I have trained my model using this specific data. So now I am giving, like, trying to understand is my model has learned accurately what I have made them understand, what I want my model to understand and interpret. Is the model successful in doing that? So I need to check it. So next, what I will be doing, I will be giving a test data. Okay, so here my test data, so I am putting the input as 2200. Okay, so based on the advanced learning that the model has gone through, the model will predict that the price of the house would be around 2000, 2,70,000 around. Okay, so if it is predicting, see, this data, the value of x. So here in the training, we have given 2000 and 2500 and 2200 somehow comes in between. So based on that, so when the square size increases by 500, the value like this price actually getting increased by 50,000 more. So this is the actual hidden pattern that the machine has understood. So now when I am asking about any of the test data or any of the square price I have given as 2,200, if it predicts it, like the price is around 2,000, say like 2,70,000, it is fair enough. Like it is coming in between. Yeah, anyone have to say anything? Dikshant Sharma, you have anything to say, Dikshant?
Ma'am, actually, you're mute. We can't hear you.
For how long I am been muted? Like how much you
Just
people have
before
known?
you came
Just
here.
just
Just
one
now,
minute, ma'am.
ma'am.
Just 1 minute.
Yes,
Just one
ma'am,
minute.
just now.
Oh,
Just now.
okay, fine, got it. Okay. So, what I was telling, okay, just a minute. So this part you understood how we are going ahead if we are giving a test data, how it is predicting.
Yes,
Yes, ma'am.
ma'am. Yes,
Okay,
ma'am.
okay, got it,
Yes,
fine.
ma'am.
Okay, so this actually what a supervised learning machine learning model does. So this is an example that I have given you. So now we'll move ahead with the
Ma'am,
like
just I have one doubt. Ma'am, I have one doubt.
yeah, yeah,
Just scroll down, ma'am. Scroll down a little
put
bit.
down or
Yeah,
up,
yeah. Little bit down, up, ma'am. Take up. Yeah, it's
yeah,
yeah, yeah. Now you are telling that little bit down, ma'am. Little bit, little bit.
okay,
Yeah, you are telling that X data, test data, we are given 2,200 square feet, ma'am.
yeah,
The Y data range, it shows the 2,000, 2,70,000, right, ma'am?
yeah.
Yeah, the value it automatically gives that 2,000, 2,70,000, ma'am.
Yeah, it is predicting, right? If my model has accurately learned from the given data, see, this is an example that I am showing, right? So,
Yeah,
this is the data, this is the trained data, right? This is the
yeah,
trained data by which I have made my model learn. Okay. If my
yeah.
model has learned
Correct.
accurately, so it will I have just given 2,70,000 just for an example. So it will
Yeah,
give
yeah,
any of the data in between because the value range come between 2,000 and 2,500, right? Because 2,200 comes in between 2,000 and 2,500. So according to the labeled data that has been given, so based on this, it will be giving this value up. Okay.
yeah. Okay, ma'am. Just we are giving sample data, and it will takes that what is the necessary thing, and it will predict the output, ma'am.
Yes, it is a prediction. Like it can't be exact accurate, but would be close to the accurate value.
But in
based on the data.
unsupervised learning, we won't give that labeled data. That means we are not giving that
Right, right.
value. Yeah. Yes, ma'am.
Yes.
Okay. Okay. Yeah. Okay.
Yeah. So this is supervised. So this data that we are providing, that is the label data. So we are giving a predefined or pre-old data is given to the model. The model gets and learn from that data. And based on that, we are giving any of the test data we are giving to the model so that or the new data, test data is new data, that data the model haven't faced before. Now we are recording how the model behaves based on the new data or the test data that we are giving. Clear? Understood?
Yes, ma'am. Clear, ma'am.
Okay, fine. So now we are just working it around and seeing like how we are like how supervised learning actually works. Okay, so we need to collect the data first. So as I mentioned, how we are collecting. So input is the feature, or we can say it as x, that is the x variable, or the independent variable because that is not depending on anything. We are directly collecting it down and output, that is the label that we consider as label, that is actually y. This is the independent because it is directly depend on y. Based on the y value we are predicting the output. Okay, so input value, it is like that. So it can be anything. Like I have just given you an example how we are creating, like on what perspective we can create the data, collect the data also. Okay. So next step after we are creating, like after we are collecting the data, before training the model, there is one very important step, like one or two very important step that we need to consider up the against 1A, we can consider the next step after data collection, the pre-processing stuff that we need to do. That is quite obvious, right? So I'm not
Ma'am,
going into
ma'am,
that.
ma'am.
Yeah, yeah,
I have some doubt, ma'am. For input features, we are taking just the size of the house. Yes, ma'am. For
yeah,
example, we can take multiple inputs, ma'am. We can
yes,
take
yes,
house,
yes, yes,
color,
definitely. So this,
or
yes, yes.
yeah. Okay, ma'am.
Yeah,
Okay.
we can. So this, for a simpler version, I have taken only one independent variable. So this is an
Okay.
example of linear regression. Just a linear, like only one variable we are considering. So it is coming under the example of linear regression. So there is an example when we are considering more x values like x1, x2, x3, we are considering, and against we are getting the output as y, only y, one value we are getting, that is multiple linear regression, that we will be discussing. Don't worry, for this part I'm just keeping it simple so that everyone understand, and eventually we will be covering everything. Fine.
Yeah. Okay,
so
ma'am.
uh, so after data collection, pre-processing is a mandatory step that we need to do, that is pre-processing. That is, we need to clean the data, we need to see the data, do the feature engineering that we already done in the last week session. All those stuff we need to do. Okay. Then what is the major part before this model learning or model training or model implementation? That is the splitting the data. The original split data basically. So we do have this data, suppose we are having, okay. So now we have to split this data because we have only one source of data. We from that data only we have to make our model learn also, and we also need to test or evaluate our model also. So we'll generally, in general perspective, what we do, we generally keep 70 to 80% for training purpose, and we generally keep 30 to 20% of this data for the testing purpose. Okay, clear? So the after this next step is splitting data basically. So we need to split the data that we have collected and pre-processed. We need to split that data into two sections. That would be training the data, and then is it testing the data. Okay. So after this, we need to take into account the model selection. So which model I want to implement and which model I need to take into account, that I need to take into consideration. That is model selection. Okay, so what we do in model selection, we choose an algorithm. Okay, what algorithm, what are the basic algorithms, we will be learning accordingly. Okay, so we need to choose algorithm. We are very well aware with of some of the basic algorithm like linear regression, decision tree, random forest, SVM. So we are well aware of the machine learning algorithms. So we will be choosing a algorithm. Suppose in case of this house price prediction, what we did, this house price prediction, what we did, we have choose an algorithm to work and train our model, that is linear regression, because we do have the label data. So we can we think it of like this, that linear regression will work good, right? So similarly, in after splitting the data, the next step is model selection, where we will be selecting a specific algorithm that will work good for based on the data that we are actually having. Okay, clear guys? Up to now, everything is clear?
Yes, ma'am. Clear,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, fine. So next step, what is the next step? This is the learning phase. Learning phase. Okay, so in the learning phase, we are coming across the training the model. Okay, so what we are doing in learning phase, the model takes into account about the patterns. See what here it does. Here we are after the model has learned. Suppose here no one is going ahead and no model is there. So based on the data, what you people are understanding, just let me know what are the insights that you people are getting from by just by seeing this data. You people tell me. Anyone?
Like based
Guys?
on the input features, we will be predicting the output, ma'am. Like
Yes.
whatever the size of the house is there in the square feet, the higher price will be predicted as output.
Yeah, that is one
There is a
insight.
certain pattern in the pricing of
Yeah.
the house, depending on the
Yeah. What
area.
is it? Yeah. What is it?
Ma'am, can I?
Like for increase of 500 square feet, there is 50,000 increase in the price.
Right. Exactly. Yeah. Anyone was about to tell anything? Someone was saying in between. Can you please tell if you have anything to say? No one? Okay, fine. This is actually the inner trend that the machine understand. Here we are trying and figuring out, but when we will be giving this, like here we have only taken four data, right? But in when we will be giving the machine, we will be giving huge number of data, maybe thousand, lakhs of data we will be giving to the machine. So now just by seeing this four data, we are able to understand what is the hidden pattern, but it is not possible for us to analyze thousands data or even lakhs of data, right? So in that case, the model will go through the data. Eventually, it will understand what is the hidden pattern. So here in this data, the hidden pattern is like with just by increasing of 500 square feet area, the price range is getting increased by 50,000, right? So this is the inner trend that is getting like getting acquired from this data. So this is the learning process. Here we are discussing, right? What is the hidden pattern? Similarly, the model, it can't discuss among itself, right? So if the trends and models, the details that would be given to it, it will be analyzing among itself and understanding like what is the pattern there between the independent variable and the dependent variable. Okay, got it?
Yes, ma'am.
Understood what it
Yes,
does
yes,
in
ma'am.
case of the
Yes, ma'am.
learning phase, like training part basically. Okay. So after the learning phase, it comes the checking phase. In case of checking phase, what we are doing, we're testing the model. So after it has, like, suppose what we do, like we have given the model this data. Now we have this data is known to the model. Now suppose after training, I am giving X, like I am giving the model input, like sorry, just a minute, X as one 1000. So quite obviously, it will give me the output, that is Y value, it will be predicting as 1,50,000, right? Because it is known to the machine, like for X, the label is Y, right? So if we are giving any known data, the model will definitely give me the correct answer. So it doesn't show what impact, like how beautifully it has learned, or in what extent it has learned. Does the model has learned in a correct manner or not, right? So for this we do keep a test data that is not there in the data set, like data set that has been given to the model, that is not there. So this 2200 is nowhere in the X part, right? So it is a very new data that the model is like facing. So based on its understanding, it has predicted the output as 2,70,000, right? So this is what this makes us understand that based on the learning phase, how we are getting and testing the data. We need to test the model like this. Then again, suppose we are okay. Then suppose we are giving the input as around 2,900. Okay. So for this, what output we will be getting? So we might get the output as 2,90,000. So that is not the obviously not the accurate value, but the predicted value would come out as 2,90,000. So that is quite understandable because here we are getting sorry, not 90,000, because it has not came up yet. 2,400 for 2,400, because the last data we have included is 2,500. So one step ahead we have taken, given the input as 2,400. So for this, the output we are getting it as 2,90,000, because for 2,500 the labeled output is 3 lakh. So for 2,400, the in obvious sense we can think it of that the output would be 2,90,000. So if the model is predicting this, so it has learned good. It has learned well. Its accuracy level is high. The like test-based accuracy level is high, right? So if not, then we have to again train the model. If similar kind of output we are not getting, then the model has not learned well from the data that has been given. Then we have to again make our model learn from the very basic. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Clear?
Yes, ma'am.
Okay.
Yes, ma'am. Ma'am, you can send this document into the group, ma'am. It is possible?
Okay, if it is possible, I will share. Fine.
Yeah, okay, ma'am. Fine.
Okay, okay. And after the test, after the suppose the model has gone well in the checking phase, we understood that the model performed really well based on the data set that we have given. Then we are putting it to the prediction phase, like how we have predicted this y value, this y how against x, how y value has been predicted. The similar way the model is used for the prediction, and then in the final step we can think it of about the deployment. Okay, so that we will be learning slowly and gradually. Okay, so there are certain ways, like steps in case of testing. Okay, so is testing phase is actually the examining phase, so we'll learn about the testing phase now. So testing phase basically. So what testing phase steps that are there in case of testing phase? So in testing
Ma'am,
phase, we train the
ma'am,
yeah, yeah. Hello.
we are moving. We are running. We are, hear me, ma'am.
Yeah, I can hear
Hello,
you.
ma'am.
Yeah, I
Yeah,
can
now
hear
we are
you.
learning about yeah. Now we are learning linear regression, ma'am. Ma'am?
No, we are not learning linear regression. We will be learning linear regression, but we need to follow the step one by one, right? Then we will be definitely
Yeah.
learning linear regression. What are the algorithms we will be learning? I will be letting you know. But now we are
Yeah.
not learning about the linear regression, okay?
Yeah. But, I'm asking
Now,
how many algorithms are there in supervised learning, ma'am?
there are many algorithms. I have listed it down as well. Here, many algorithms are there.
Yeah,
Many
okay, ma'am.
algorithms. Okay, so we'll be discussing. Just have some patience. I will be telling you everything. Just have some patience. Okay.
Yeah, okay, ma'am. Thank you.
Yeah. So in the testing phase, that is the examination phase. So once the model is properly trained by the data, we need to check if it is actually learned well or not, right? So the steps that we are following up here, let me just write it down for you. Steps, yeah. So the very first steps that we are considering up here, use the test data. Previously, we have given, suppose here we have taken some of the data, right? So previously where I have written, yes, here splitting the data. So once we have the data, so we have just split it into two halves. One with the 80%, another is 20%. So this 20% data we need to use in the testing phase to to make the model know make understand the accuracy level of the model. So the very first step or the very first way of testing the step using that we are getting is use the test data. Okay. So next, sorry. Okay, let me just put it down itself. Okay. So the second step that we are considering up here, that is we need to make the prediction. So make the prediction means the model predicts output based on the learned thing that is has got, right? So the model is giving us the output based on the learning that has been made in the training phase, right? So we need to get the predictions out. We need to make the predictions. Suppose the model says pass, we need to suppose based on any of the data the model says pass. So we need to understand that might not be the accurate value, but that is the predicted value that would be near to the value. We need to check if how close the predicted value is from the actual value. So we need to make the prediction. Understood, guys? What I told you?
Yes.
Okay.
Yes, ma'am.
So yes. So yeah, anyone saying anything? Okay, got it. So, based on that, the very next step after making prediction, that is compare the actual value. Okay. So, in this case, what we are doing, compare the actual value. So, for this example, we have given the input that is x as 2200. Okay. So, suppose here I am writing it down. X, we have taken it down as 2200, right? So we know the actual value. What exactly is the price of the house? The actual value we know. Suppose the actual value is around 2 lakh 75,000. Okay, understood? This is the actual value that we already know from the data. Okay, but what the model is predicting, that is what we are getting in output, we are getting 2 lakh 70,000, right? So what is the difference? Difference, difference that we are getting. So what we will be doing? We will be doing a minus y. So what we will be doing? 2 lakh 75,000 minus 2 lakh 70,000 we will be doing. So what is the balance that we are getting in? So we are getting 5,000 is the balance, right? Understood? Understood what we are doing in this step? That is actual
Yes, ma'am.
Yes, ma'am.
Yes,
comparing
ma'am.
the actual value. Yes. So in the from the beginning, in only from the test data, we will be getting the actual value, right? So, but we will be seeing what the machine is predicting or what the model is predicting. So we will be doing the difference we have got. So it is the difference that we are getting. So this much error, the like this is called the error. This is the error part. This 5,000 is the error that we are getting. So for this model, this is the error. Suppose we are making another model, you giving the same data itself. Okay. So suppose for that data, the y value I am getting it around 2,74,000. Okay. So then the difference would be how much? Then how much would be difference? That would be 1,000 only, right? So I can definitely predict that this second model. So this is for second model. Okay. So from there, I can definitely predict the second model works better than the first model because here I am getting the error of only 1,000. Right? So I can definitely predict the second model works definitely better than the first model because in case of the first model, the error was 5,000, but in case of the second model, the error is only 1,000. Clear, guys? Understood?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Everything is clear?
Yeah, ma'am.
Yes, ma'am. Everything is
Yes,
clear.
Clear,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Okay, fine. So after this comparing the actual value, what we are doing, we are actually evaluating. So this difference, how we are taking into consideration, how we are comparing that I told, that comes into the evaluation performance part. Okay. So sorry. So evaluation performance part basically. So what are the measures or the values we are taking into consideration here for the simplicity purpose? We have taken into consideration the difference. Okay. But in general purpose, when we will working with the high level data or industry level data, we are taking into consideration the evaluation matrix as accuracy. Then we are considering precision, recall we are considering, F1 score we are considering, and we are also considering mean squared error, MSE. Mean squared error. Mean squared error is basically used in case of regression problem. Okay. Clear up to this? Clear up to what are the steps we are following in testing phase? Clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So
Yes,
you
ma'am.
can Okay, great. So you can see this diagram, right? So this is the algorithm, this is the logic, and this is the two phase actually it is being showing. Okay. So what we are doing, suppose we are putting is as input, giving the algorithm up, and we are getting the logic, right? So similarly, here in the model, what we did, we have given the input to the machine, okay, and also the label data. Now what it is doing, input in this case, we are here in this case, input we are giving all the x and y value, the previous, the training data actually, okay. In case of what it is doing in algorithm and getting output as logic, so what it is doing, it is actually understanding the hidden pattern up. Okay. So in the testing, what it is giving, when we are giving a single input against the logic, it is giving us the output. What is our prediction based on the based on the result? What is our output that it is giving? So this output part we are getting in the testing phase, And in the training phase, we are making the model understand based on the data that we are giving it. Okay. So here it's been written like supervised learning model is trained on the data set to learn to map function between input and output. What I told, they have just mentioned it in this format that they learn to map the function between the input, this is the input, and this is the output. What exactly the logic or the hidden pattern that we are getting that the model is learning. And then the learn function is used for predicting new data. Okay, clear,
Yes,
guys?
ma'am.
Great.
Yes, ma'am.
So yes, yesterday only we
Yes,
have
ma'am.
gone through. Yes, yes. Okay. So yesterday only we have gone through and understood about the two types of data, that is supervised and unsupervised. Okay. So we can think of some of the real-time example also, real-life example that we can think of. So the very first thing that we are thinking of in case of training, we can think of like the email, the spam email classifier, right? So in case of spam email classifier, that works good in case of this supervised learning. That comes under the supervised because we need to predict like is the value not present or present, is it a spam or not spam actually, so that comes under classification. And regression, the data that I have, like the example that I have given you, that is this prediction of house price, that is an example of regression based learning. Okay. So we have learned about what steps we are following in case of the training. Here also in the testing we have taken into consideration. So we have one thing that we need to consider up here, that is hyperparameter tuning. After evaluation, we are doing this hyperparameter tuning and then the final model selection and testing. Right. So there are certain phases, terms or terminologies that we need to understand that is directly based on the data and the model basically. So the very first thing that, okay, just a moment, like let me just go down and let you know about those stuff. So the very first thing that is overfitting. How many of you know the term? Like how many of you know what overfitting is?
Uh, when a model predicts work well on the our given data set, but perform very poor on new data set.
Okay. So anyone else?
Ma'am,
Ma'am, when
overfitting is
Ma'am,
when
when
we uh,
One by one, please.
okay,
data
let
is
me start it.
loaded over data loaded.
Overfitting
Over
is
data
actually
loaded.
when we
Yeah.
train our model with
Mm-hmm.
a very specific data. If I talk about like if I train my model about a ball and it's about a basketball and the radius is 4 or 5 or 6, so it will don't predict the tennis ball as a ball because the radius is not matching. So in overfitting we
Exactly.
actually provide lots of data to train, and that's when the model gets stuck.
Okay. Great. Great. Great example. Nice. So what actually he told, that is quite impressive, and what he told is actually correct. Okay. So what we are doing in case of overfitting? So overfitting happens when it happens. It happens when the model learns too much from the training data. Like it learns against the training data too much. It might, like suppose it's not like the data that we are giving is absolutely correct, right? There are situations that might include that our training data contains noises, mistakes, or even very specific details might be there in the data, in the training data. So the model is learning from that, right? So because it is learning from that, it is putting everything into that, like every new data into consideration based on that only. So Based on that, suppose if we are having a data set and we are giving any of the learned data, of course it will be giving the output as same because it has already learned. But in case of new data, it will fail to give us the accurate result in case of new data, right? So based on the criteria, we need to check the training data properly. So suppose we can think of let me recall an example. Suppose in the question, we can you can imagine that you are preparing for an example, preparing for an example, sorry for the example thing. You are The example is you are preparing for an exam, okay? So instead of understanding, suppose there are certain students, what they do, instead of understanding the concept, you just memorize all of the questions and answer of the last year, whatever, like the last year paper. We do have a tendency of practicing last year questions. But what some students do, instead of understanding the concept, what they do, they memorize all the questions and answers of the last year's paper. Okay. So in the exam hall, if the same question comes, that is the last year's question, you will definitely work good, right? Your paper will be very good. You will be performing very good in the exam, and you might get 100 on 100. But when there is a very new question that appears and it is basically based on the concept, the student won't perform well. The student will get stuck, right? So that is exactly the case of overfitting. So what we can say in short, overfitting is memorizing instead of understanding. When the model is just memorizing the data instead of understanding or analyzing the what trend the data is following, then we come across to the problem that is called overfitting. Clear, guys? Understood?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay.
Yes.
So similarly, we do have as I mentioned, let me just try it, write it. That is memorizing instead of understanding. Okay. Next problem that is that we are thinking it of, it is underfitting. So anyone wants to tell about underfitting?
When a model is too simple to learn new patterns from the training data, so it performs bad on both tests and data set.
Exactly, exactly. So underfitting happens when the model performs badly on the training data. Like in the training section itself, it has like in case of overfitting, we understand the model is overfitted only when we come across in the testing phase. But in the underfitting section, the model doesn't perform good in the training section only. Then there is no chance of the model to perform good in the test section, right? So it doesn't perform good in the training set only because the model might be too simple or too blunt, also we can say, and cannot learn the patterns, the hidden pattern that has been mentioned in the data that has been given, right? So in that case, we are facing this condition that is called underfitting. So you can think of you only read one page summary notes. There is certain two students who have an understanding or thinking that if one just one page summary one will understand, that will help them to go ahead in the exam and pass in good marks. But that is not possible. Like in exam, you can just answer in simple question just from the summary part, right? There is a high chance that you fail only because you don't know the chapter only. Just from the summary, getting the idea about the whole chapter is not possible. So this is a part of underfitting. So underfitting, we can definitely conclude and tell not learning enough. Underfitting comes into the condition where the model is not learning enough. Okay. So the next step that we can think of, it is cross validation. Okay. So cross validation, we can think of it is a technique to check if our machine is reliable or it is not reliable. Like is it performing well for only one single data set, or it is performing like it is vast. It can be like we can think it of as a versatile. It can perform well for other data also, right? So cross validation is the technique where we are checking if our machine learning model is reliable or not. Okay. So instead of training and testing the model only once, we train and test the model multiple times and in multiple parameters. Okay, so that we can understand and make our model ready for each and every situation it faces. Clear? Understood about cross validation?
Yes, ma'am.
Yes,
Yes, ma'am.
ma'am.
Okay, fine. So cross validation we can think of like testing our model on multiple parameters and multiple times and on different sliced data. So to make sure the model is strong, fair also, and also generalized well. Clear?
Yes,
And
ma'am.
the
Yes,
very
ma'am.
okay,
Yes, ma'am.
and the very next thing that we can consider. Okay, let me just write it. What is cross validation? That is testing testing our model multiple times on 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 different data to make sure it's strong, fair also, and generalized as well. Okay. So the next step, like the next thing that we can think of, that is hyperparameter tuning. So anyone wants to put in any idea about hyperparameter tuning? Anyone? Okay, let me just explain. So, am I audible to you? Or like, are you people able to hear me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine, fine.
Yes, ma'am.
So, hyperparameter is like setting or knobbing in a machine. Like we can think of when, like, how, like, let me just give you an example. Like we can think of we are just baking a cake. Okay, so what we are doing in hyperparameters, what are the parameter we will be choosing, like the temperature of the oven, or the baking time that we will be taking, or amount of the quantity. Suppose in cake, baking a cake we would be needing flour. What is the quantity of the flour, what is the quantity of sugar, the milk that we will be adding, what would be the quantity of that. So that are the actual the parameters. Okay. So each parameters is important up here. Suppose we have taken the parameters like woven temperature, right? Next, the baking time we have considered. Then the like the ingredients quantity we have considered. Suppose if the temperature is too high, then what will happen in the outcome? The cake will burn, right? Then we can consider that that is not fair enough. We won't take this cake because the cake is already burnt. Okay. Next, if the quantity of sugar or milk is more, so how the taste, what would be the taste of the cake? It would be too bad. We don't like excess sugar in our cake, right? So it will like affect the taste of the cake. And secondly, if we are like baking for longer time, it also make our like it also burnt our cake, right? So there is certain like adjustments that we need to make the cake perfect. So here also you can definitely conclude cake as a model. So as we are like all these parameters that are there inside it, like inside that is needed to make the model, need to be well balanced, well equipped, so that we get a fresh and good cake that is good to taste, that is spongy also, that is not burnt also, right? Are you people understood what I am trying to say? Guys, understood?
Yes, ma'am.
Yes,
So
ma'am.
the example is clear to you what I am trying to say, what actually hyperparameter is?
Yeah, ma'am,
Yes,
got
ma'am.
it.
Yes,
Okay.
got it.
So we need to tune, like we need to make the adjustment in the basically what is the parameters that we are getting in the data. We need to tune that. We need to adjust that to get the best performing model. Okay. So this is actually what hyperparameter is. So there are types of hyperparameters. Okay, so hyperparameters we can think of what are the hyperparameters that we can think it of? Yeah, that is learning rate. That is specific in case of neural network. That is, we get learning rate in case of neural network or we get it in gradient descent. Okay. Next, we are having like the types of like more common things we can think of about the number of trees also we can consider. Sorry, number of trees in case of decision tree. In case of decision tree. Next, we can think of also in case of decision tree. Also, there are other like random forest is there. Next is XGBoost is there. Don't worry, we will be understanding each of these algorithms in details. Okay. Before that, let me just tell you like what are the like parameters that we can consider up. Okay. Next, number of trees in case of depth of the tree, also in case of decision tree, depth of the tree, in case of decision tree. Next, the number of neurons or layer, that is in case of neural network. Maybe all of the neural network, convoluted neural network, or a recurring neural network, or whatever be, we are considering it. Okay. So what it does, suppose in case of learning rate, if it is too high, then the model is overshooted. If it is too low, then the model learns slowly. Even in case of the number of trees, like in case of random forest, XGBoost, what it does, if more number of trees are there, the accuracy would be better, right? If there is too small, like too many numbers of rows, or where there are very less number of rows, then we can get the problem of overfitting. And if the number of trees is low, we will be getting the problem of underfitting, right? In case of depth of the tree, like the smaller depth, like the problem is when the model is too simple, then we are getting the problem of underfitting. If the depth of the tree is very deep, there is we are getting the problem of overfitting. So clear, guys, how we are using this hyperparameter tuning part to understand and implement, make our model the best to work.
Yes, ma'am.
Okay, okay, got it. Fine. Uh, Okay, so we'll just stop here today. In tomorrow's session, what we will be going ahead, we will be like discussing about this stuff like final, like the deployment part we might discuss, and eventually we will be going ahead and learning about the different supervised machine learning algorithms. Okay, clear, guys?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes,
Okay,
ma'am.
so we'll end our session here only, but I have something important to discuss with you. Okay, just a moment. Yeah, yeah. So first thing is We will keep today's session here itself. We'll like wrap up our session here, but there are certain things that I need to discuss with you. The very first thing is will not go to the presentation from tomorrow. Okay. So what people will be doing, whoever is left for week 1 or week 2 project, just raise your hands. If it is week 1, then also raise hand. If it is week 2, then also raise hand. Okay. Okay. 18 people as of now, right? 19. Okay. So we'll do one thing. What you will be doing, you will be just as I mentioned yesterday, you will be recording your video using Zoom, and you will be sharing the screen. Keep your mic and camera on. Present your presentation, whatever be your presentation up. Just present it in front of the camera. Explain it in whatever format you have done, and just put that video file in your drive, Google Drive, and give us the access to see it, and just paste it like just give us the like mail us the link. Okay, so that we can just see whatever you have put in through. Okay, understood, guys? What you need to do, you understood? You can switch on your mic and tell.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, 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 got it,
Yes,
fine.
ma'am.
So, yeah. So, anyone having any issues related to any other stuff? Some people was asking related to.
The guys who have presented both, the guys who have presented both, no need, right,
Don't
ma'am?
have to. Don't have to. Yes. Don't have to. Who have
Yeah, okay.
already presented in the session, they don't have to do it. Okay. This is for the one who haven't done it, they have to do it. And for session 1, most of you have presented, right? Some of you are left. I guess 5, 6 people are left of doing that. So you will be doing that for both week 1 project and week 2 project. Okay.
Excuse me, ma'am.
Okay. Yeah.
Ma'am, can you tell the title of the week one and week two projects, ma'am? Like, what is the work project about?
So, see, that was already been given, and PDF file has been given to you in the group only, right? So you can just refer to that, and based on that, like there are multiple of projects has been given. You can choose accordingly what suits you the most. You can choose it, and based on that, you can go ahead and work in any of the model you like any of the project you want to. You can work.
Ma'am, but in that only we got the week one PDF file of the project, ma'am. What about week two?
Okay. Week 2. Okay, you can just drop a mail to the HR department to share the project details to you. Or if not, I will try from my end to tell them to share the project.
Okay, ma'am. Thank you.
Yes, Bipsha,
Yeah.
what's the issue?
So they have not like some of them are new, so they have not received the week 2 project list. So can you just share it in the group again?
Week two project list.
Yes, yes.
So,
Week 1, week 2 project list.
okay, I'll share in the group.
Okay, so.
So this is for which, for AIML, right?
Yes, yes, yeah, I am.
Okay, fine, I'll share.
Okay, okay. And it's like I guess most of you have already got the offer letter, right?
No, ma'am,
Right?
I didn't get my
Yes.
offer
Yes,
letter
ma'am.
yet.
Yes,
Yes,
ma'am.
ma'am.
Who
Yes,
like
ma'am.
who have joined within 2 to 3 days or last week only? It might take some time for them, but rest of you have received it, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
okay, got it. So it's mandatory that you share it in your LinkedIn. I guess all of you are having the LinkedIn account, right? You just upload your offer letter in your LinkedIn and tag the company. Okay, tag our company.
I already
Okay,
uploaded, ma'am.
Already. Okay, great. Who have already done? That's good. Who have not done, please do it. Fine?
Yes, ma'am.
Okay, okay. So
Guys,
I guess
take this very seriously, because if you will not going to do this, your session will not be continue. Okay, so just upload it in the LinkedIn and take the screenshot and share it to the HR mail ID for the confirmation of the same. If anyone received the offer letter and is not sharing in the LinkedIn, then the session will not be continue. So keep this in mind. Thank you. It is a mandatory process. Yes, ma'am. Over to you.
yeah. So I guess everything is clear, guys, right?
Yes,
Yes,
ma'am.
ma'am.
Okay. So any other question? Anything you want to ask?
No, ma'am.
Okay. So we'll just wrap up our session today here.
If it
Okay.
is part, ma'am,
Yeah. Yeah, yeah, tell.
ma'am, once again, remembering, ma'am, if it is possible, share the documents, ma'am.
Sorry, I just missed out.
Yeah, if it is possible, share the documents, ma'am, for machine learning.
What documents I didn't get you?
What document, ma'am? Which now you have teach, now you have taught, right, ma'am?
Okay, okay. This one, right?
Yeah, yes, ma'am, yes, ma'am.
Okay, okay, got it. So we'll be starting from here, right, tomorrow. So here we will be continuing here itself. So you can check, like, after we have completed, if possible, I will be definitely sharing with you. Okay? Don't worry on that.
Yeah, okay, okay, ma'am.
Okay? Yeah. Okay, fine. Okay, then bye. Bye, guys. Dikshant, you have anything to ask? You have raised your hand.
Thank you, ma'am.
Thank you.
No, ma'am.
Okay, fine.
Ma'am, I have a doubt. Those person who join today, so what's the
Yeah.
task they have to do?
Okay, got it. So similarly, it's each week we are going ahead with this training sessions. Okay,
Okay,
after
okay,
each, like after the session, on Friday, actually, you have been given with the project, and
okay,
by Saturday, Sunday, you have to complete the project and accordingly submit it by Monday. Okay, and you have to present it accordingly, right? So
okay.
this is how we are actually working up, right?
So
And you have,
for now I
yeah,
don't need
please,
to do any project.
yeah, you need to, because the thing is, you have joined 2 weeks late. Like this is the third week project, that is like third week that is going on. Okay,
Okay,
so you will be given with the recordings. Don't worry. You can check with those recording, and you will be getting the project access as well. Like whatever, like what on what criteria you have to go ahead with the project and stuff, that you will be getting the PDF
okay,
file. You can choose accordingly from the file which project you want to go ahead with, and accordingly you can work for week one and week two project. You can, since you have joined late, you can take some time, but you have to submit the project, and accordingly, as I told, you need to showcase your, like you need to put use the Zoom app application, present your project, and accordingly present the presentation of the project accordingly, and you have to submit it. Okay, got it, Arya?
when will I get those list of project?
I guess you are there in the WhatsApp group, right?
Yeah, I am in that.
Yeah, yeah. So we'll be sharing the details there itself. You just stay active there. All of the further details will be will be, you will be getting there itself.
Okay,
And if any question, any, like, see, after every class, we do keep 10-15 minutes of taking doubts, whatever be it. So here, any doubts, any issues you are facing, you can definitely ask. So I'll be there to help you out if it is related to the course or anything. Okay?
Okay, ma'am. Okay.
Okay.
Thank
So
you, ma'am.
you joined today only, right? Today is your first session.
Yeah, it's my first session.
Okay, okay. Got it. Fine. So you are from which university?
I'm from Galgodias University.
Okay. And you are doing BTech?
I have completed my BCA this year. I'm a
Okay.
recent pass out.
BCA you are.
Yeah.
Okay, okay. Got it. So in 2025 only you have passed out, right?
Yeah.
Okay, okay, got it. Fine. So accordingly, you go ahead and see how the classes are going and like the sessions are going, and accordingly you can start working like side by side, start working with the project. I think it won't take much of the time to you to cope up.
Yes, ma'am. Okay.
Okay.
Yeah.
Okay, fine. Okay. Bye.
Thank you. Thank you.
Yeah. Bye bye.